Okay, let's wrap up this section with probably a little bit more traditional look at slope that you've studied in the past. So my example here is explaining slope in a kind of a real world setting. So it says here that some roads are steeper than others. So envision having two hills that you're driving on where one is steeper than the other. So a steeper road has a greater rate of change. So think about that in terms of slope. It's going to be a larger number. So the bigger the number, the bigger the slope. So therefore a slope of 5 would be a lot bigger or steeper than a slope of 1/2. So let's fill these blanks in here. How about the first one? Let's do slope. The slope of a line is its rate of change. So on the previous page, we looked at rate of change with respect to tables and graphs, but we were really looking at slope. So another way to look at slope, it still can be thought of as change in y over change in x. Actually, let me add that down here. Slope is the vertical change. So think about vertically on a graph, that's the y-axis, over the horizontal change. There's your change in y over change in x. Rise over run. When you rise, you go up or down, run left or right. Y2 minus y1 over x2 minus x1. So when we were going down the table of values, we were really taking the second value and subtracting the first. So let's add at the end here, equals change in y over change in x. All right, so there's many ways to say the same thing. So just be comfortable with seeing the different options. Okay, going back to some of the basics here. Oh, also slope. Letter M is what we'll use to define slope. So these two graphs are showing the slope. So the vertical change or the rise, this is going up 2 over 5. So one thing I like to do is look at, this is increasing from left to right. So I know this is a positive slope. I'm going positive 2, positive 5. So the slope here is 2 over 5. Here, one way to do this would be to say, okay, this is a decreasing line. I know the answer is negative. The other way to look at it is saying, well, I'm going down 3, that's a negative 3. I'm going to the right 5, that's a positive 5. But sometimes I find students kind of mix up and down seems pretty easy, but then left and right, sometimes we mix those up. So my slope here is negative 3/5. So that's what I would recommend. I would decide before you start, are you going to have a positive answer or a negative? So if it's negative, the negative should be out in front. If it's positive, of course you won't have any sign there. Okay, I want you to pause and do the next two. I want you to do number 3, A and B. Find the slope of each line. Okay, letter A, 3/5. Counted up 3 over 5. Letter B, it's a negative, so negative down 1 over 6. So the slope is negative 1/6. All right, let's look at this next example, and we're going to use what we often call the slope formula. So find the slope of the line through negative 2, 1, and 6, 7 using the slope formula. So I can't really count rise over run very easily because I don't have a picture. So this right here, I'm going to circle it, is the slope formula. So let's start by writing that out here. So m is equal to y2 minus y1 over x2 minus x1. Change in y over change in x. So if it helps you to label, we can do that. So I can call the first ordered pair x1, y1. I can call the second ordered pair x2, y2. So you're taking the second y minus the first, the second x minus the first. So I'm going to take my 7 minus 1. second y minus first y. And then go back, my second x is 6 minus negative 2. 6 minus negative 2. Okay, 7 minus 1 is 6. 6 minus negative 2, those are going to cancel out, so it's really 6 plus 2, which is 8. And we always want to reduce that down. So divide both by 2, so that would be 3/4. Okay, slope is 3/4. Or you could also make a table of values like on the first page. If this is easier for you, you could say -2, 1, 6, 7. And you could say this is going up by 6. This is going, oh, let's see, it's going up by 8. There's your 6 over 8, and then you can reduce it down. You could always make a table as well. Okay, last couple. Find the slope of the line. All right, so these are sometimes called like special lines because they're horizontal and vertical. So the slope of a horizontal line, there's a couple ways to do this. You can just flat out remember the differences between the horizontal and vertical, or you could kind of calculate. So to flat out remember, slope of a horizontal line, it's like walking on the ground. There's no slope to it, so the slope is 0. Okay. The other way to sort of calculate it is put a couple points on your line. Okay. So my rise is 0. I'm not going up or down. My run is 3. 0 divided by 3 is 0. All right. So slope of all horizontal lines is 0. The slope of a vertical line is undefined. So it's not a number, it's this word, undefined. Now you could kind of sort of calculate this, but you have to know a little bit along the way. So you could still put a couple points. So let's say I'm rising 2, I'm running 0. Well, 2 divided by 0 you have to know is undefined. So this calculator gives you a divide by 0 error. It doesn't come out and say undefined. But you do have to know you can't divide something into 0 groups. It's at least divided into 1 group. So that's why we call it undefined. So again, you can kind of memorize. I mean, I've heard people say like, you know, the horizontal slope is super easy. Like think about walking, super easy. It has absolutely 0 slope. Vertical lines, like you just can't walk on something that's completely vertical. Like if it were, I don't know, some kind of a hill, you would just fall. You couldn't walk. Doesn't really help explain the word undefined, but you'll have to come up with some sort of technique. Okay, that wraps up our first section.